Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
This one small surd step, just a missed factor inside a root, cost dozens of students a method mark on last year's AQA higher paper. It looks tiny on the page, but it changes the whole answer. Stick with me for the next 10 minutes, and you won't be one of those students.
Sound familiar? I always panic when I see a root sign with big numbers under it.
Good. That panic is exactly why we start here. First, what is a surd? Simply put, a surd is a root you leave in exact form, like root 2 or 3 root 5, not an approximation like 1.414. Examiners want exact answers whenever the question asks for them.
Concept. Let's simplify root 50. Look inside. 50 equals 25 times 2. So root 50 equals root 25 times 2 equals 5 root 2. That step, spotting the square factor, is the step many miss. Write it down. Root 50 equals root 25 times 2 equals 5 root 2. So you're literally taking numbers out of the root when they have square factors?
Exactly. You can only do that when the factor is a perfect square. 4, 9, 16, 25, and so on. Another example. Root 18 equals root 9 times 2 equals 3 root 2. Now, if you had root 50 plus root 18, you would write 5 root 2 plus 3 root 2 equals 8 root 2. Don't simplify to decimals until the very end. Decimals lose you marks.
Why does this work? Because for non-negative numbers, square root AB equals square root A multiplied by square root B. It's a direct algebraic rule. Use it to split roots into a rational part and an irrational surd part. Let that sink in. What about multiplying surds? Is that the same idea? Yes. For example, root 2 multiplied by root 8 equals root of 2 multiplied by 8 equals root 16 equals 4. Recognize when multiplication converts a product into a perfect square. That's another quick simplification trick examiners love. Now, the second big concept, rationalizing denominators. Exams often expect exact answers with no surds in the denominator. Take 3 divided by 2 plus root 3. You rationalize by multiplying numerator and denominator by the conjugate, which here is 2 minus root 3. So multiply top and bottom by 2 minus root 3. Work it through. Numerator becomes 3 multiplied by 2 minus root 3 equals 6 minus 3 root 3. Denominator becomes 2 plus root 3 multiplied by 2 minus root 3 equals 2 squared minus root 3 squared equals 4 minus 3 equals 1. So the whole fraction simplifies to 6 minus 3 root 3. Nice and exact. No surd downstairs. That difference of squares trick makes it much cleaner. But where do marks come from in an exam question like this? Exam technique. A typical 3-mark surd question is graded M1, M1, A1. M1 for identifying and starting the correct method, here multiplying by the conjugate. The second M1 is for carrying out the algebra correctly, multiplying out and simplifying the denominator to a rational number. The final A1 is the exact simplified answer in simplest surd form. Common slips that lose marks: forgetting to multiply the numerator by the conjugate, sign errors when expanding, or failing to fully simplify after rationalizing. Another frequent mistake is approximating early, writing 2 plus root 3 approximately 3.732 and working with decimals. That loses method marks because the examiner can't see exact algebraic work. I've definitely been guilty of early approximation. What's a quick routine to stop that? The Quick Win, a 30-second, 3-step routine you can use on every surd problem. Step 1. Simplify every surd to simplest form. Take out perfect squares.
Step 2. Rationalize only if the question requires an exact form, or if there's a surd in the denominator. Step 3. Substitute back or compare decimals as a final check. Do those 3 things every time and you'll catch most errors.
Practice check example. Rationalize 5 over 3 plus 2 root 2. Multiply top and bottom by the conjugate, 3 minus 2 root 2. Numerator, 5 times 3 minus 2 root 2 is 15 minus 10 root 2. Denominator, 3 plus 2 root 2 times 3 minus 2 root 2 is 9 minus 2 root 2 squared is 9 minus 8 equals 1. Final answer, 15 minus 10 root 2. That's tidy. If you had made a sign slip, you'd spot it by approximating both original and your answer. 5 over 3 plus 2 root 2 is roughly 0.1716, and 15 minus 10 root 2 is about 0.17162. 2 quick decimals and you're safe.
So write the method clearly, then do a decimal check at the end if you're unsure. Clever. Guided practice notes. What you should write in the exam to collect marks. Line 1. Multiply top and bottom by the conjugate, 3 minus 2 root 2. Line 2. Show the multiplication and simplify the denominator to a rational number. Line 3. Present the exact simplified answer. Examiners want the algebra. Write it down. Don't just think it. 2 fast checks to catch errors before you hand in. Check 1. Is every surd in simplest form? If not, factor out square numbers and simplify. Check 2. If you rationalized, approximate both the original fraction and your final answer to 3 decimal places. They should match. That catches sign errors and dropped factors in a few seconds. Any last exam tips specific to surds?
Yes. Write down intermediate steps, even if they seem obvious. M1 marks come from method. Circle your final exact answer and, if time allows, do the quick decimal check. And remember, rationalize only when required. Don't waste time changing perfectly fine answers unless the question asks for exact form or has a surd in the denominator.
That's your quick win for today. Simplify surds, rationalize carefully, and always check with a quick decimal if you're unsure. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable surds cheat sheet at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.